Hello everyone, and welcome to this week's Udacity Deep Reinforcement Learning Nanodegree weekly webinar. This week I'll be focusing on the Navigation Project, which is coming up for a few of you. Some of you may have already started, and some may be just going through the value-based material. But what I thought is to have a bit of a walk through the project itself, the code, the requirements, and also just some environment setups, just to try to help you, easily get through the project. And if you're having troubles, hopefully this will give you a little bit of an idea. Once again, though, if you are having issues, contact myself, and I'll try to help you. So, first of all, what will I be covering? So basically, I'll be covering the instructions to the project, just an overview of it, the evaluation, project submission. We'll be going into the rubric to sort of, which is very important for the project. Then if you're not sure where to start, I'm going to go through just some possible places to look at, how to make your project stand out, and also optional challenge the pixels of this particular project. I'll be going through a bit of a code walkthrough within the workspace, and also going through environment setups for Windows, Mac Linux, which I'll be doing on a Ubuntu system, AWS, and then some extra reference material that I'd recommend looking at, and also then a Q&A as usual. So, first, the project instructions. What do you need to do? Well, basically, this project is accumulation of what you've learned in the value-based methods and the previous introduction, and you'll be trying to train an agent to solve a environment provided. Now, this environment is a Unity environment and has different versions depending on your operating system. Now, you must submit the project. You'll be provided a GitHub repo with your implementation. You can also zip your project and send it through. Now, the requirements are in the project rubric, which I'll go through later. And the format of the project is very open. So a lot of people will do the project in a Jupyter notebook. People may train it in different ways. You may separate out your classes. You may use base code from examples. You may completely write from scratch. We don't really care how you implement it. What we care about is that you, do the requirements set out in the project rubric, and that you can show understanding and implementation required for the project itself. Now, just an overview. So, the project, you will train an agent to navigate and collect bananas in a large square world. So it says square world, it's actually a 3D world, probably very similar to Doom, the old first-person shooter. And it's quite a simple environment, which is good, for your first project. Basically, what you do is your agent will cruise around or navigate around, and it will get a +1 reward for collecting yellow bananas, which it just needs to walk over. And we'll get a reward of -1 for collecting blue bananas. So thus the goal of the agent is to collect as many yellow bananas as possible while avoiding blue bananas. Now, this is within a certain set time. The environment will is episodic, so it will stop after a particular time. Now, the state space which is provided is a 37 dimensions and contains agent velocity along with ray-based perception of the objects around the agent's forward direction. So it's not a huge amount of data coming in for a deep reinforcement learning compared to pixels or other methods, but it means that you definitely don't need to use a convolutional network. Now, the state space or observation space. Sorry, that's actually meant to be the action space. That's a typo. There are 4 discrete actions are available. This would be 0, 1, 2, 3 in an array. So if it was predicting basically moving forward, moving backwards, turning left and turning right. As I said before, the task is episodic. So it has a start and a finish. And to solve this environment, your agent must get an average score of plus 13 over 100 consecutive episodes. So you'll need to record the cumulative reward for each episode, and then do a mean of that to find out whether you've achieved that average score. Your project will be reviewed by, so for evaluation, your project will be reviewed by a Udacity reviewer against the project rubric. It will review the rubric thoroughly and go through it quite in detail, because it's quite important, because it is the requirements to pass the project. It doesn't matter if you add extra things, as long as you've covered what's in there. So everything must be covered. So I'm going to go through that quickly now. Just going to bring that up. Give me a moment. So here is the rubric for this project. So as you can see, it's separated into training code, a README, and a report. So the training code. The repo or zip file, if you want to do it that way, includes functional, well-documented and organized code for training the agent. The code must be written in PyTorch and Python 3, so you can't write it in TensorFlow. You can do a TensorFlow version of it, but the actual project must be in PyTorch. You have to save the models of a successful agent and have that as part of the submission. Then the other section is the README. So the README, or either in GitHub or in a zip file, basically must have the README in the root of the repo. The README describes the project's environment in detail, so talk about the state, the action space, and when the environment is considered solved. So pretty much what I just talked about previously. The README has instructions for installing dependencies, so you might have to show the steps to get it up and running, and that's what most projects do, or a requirements.txt with maybe a setup. So you can just do a pip install dot or something like that, or install requirements, depending on, that's probably the nicest way of doing it. The README should also describe how to run the code, how to train the agent, and basically, just go through, look at other GitHubs and just sort of see how they show their READMEs for different projects. Now, the last section, the report. So the report can either be in a README, a report.nd, a report.py.nb, or report.pdf. So you could write a separate PDF, or you could do the report within your Jupyter notebook that's actually got your code, and you could have it sort of explained as you go through it, as you're doing the report. Or you can do both. You could have it explaining and also a more detailed report. The learning algorithm. The report clearly describes the learning algorithm along with the chosen hyperparameters, and also describes the model architecture for any neural networks. So, and then you must plot a reward per episode and show the average reward over 100 episodes, or at least plus 13. Submission report, numbers of episodes needed to solve the environment. So it also has to show how many episodes it took. The submission has concrete future ideas for improving the agent. Now, what I suggest with the rubric is, before you submit, go through and make sure this is ticked. Evaluate it yourself. Go over it and double check that this is, you have, tick it off. Just print it out and tick it off. And if it's not ready, you haven't done all of this, then basically resubmit for later. Sorry, not resubmit. Wait till you've actually got it correct and then submit later. Now, the next section, GitHub submission. So I would definitely recommend using a GitHub submission. This is probably for two things. It gives you an idea of how to use GitHub if you're not used to it. It also is how most people present their work And it's also good to give you a bit of a portfolio. So, part of the doing this course, you're also trying to do your LinkedIn, your GitHub, and trying to present yourself for the world, and just so people can understand what you're, what you can achieve. So, basically make sure that you cover everything that I just explained in the rubric. So the README, code is all there, and report detailing your learning algorithm. So this is quite important. Now, if you can't do it through GitHub, the other option is to zip it up and submit it through Submission. I think, if you cannot do this, try to do it through GitHub. It's a much better idea. But also, if you need to, and this is what you prefer, this is another method. Now, you're getting that. So actually, before we go to where to start, I'm going to bring up some more information with the project itself. So 2 seconds. Now, the project is under value-based methods, of course. It is, if you go into view lessons, it basically will have a lot of what I've just explained. A few variations in some of the stuff, which I'll explain for the environment setups. But the overview is I'll read through this thoroughly and also use my video to help you out. Now, if you're not sure where to start, this is some of the suggestions provided in that material. So look at the DRLND paper. Read through it if you haven't already done it. You should have probably done it as part of your course material. But read it again and try to get a better idea of how it sort of works. The next thing I would do is study the coding exercises that are provided in the DeepQ network. This will give you the best base to look at. So go through the implementation that is for the lunar lander. It's a gym task. So basically the way you'll be laying out your main loop and plugging your agent will be very similar to this. Really take time to understand the code. So go through every little bit of it. Do prints of every line if you're not understanding what's actually going on, and just tweak it, play around with it, see if you can get it working better. What happens if you add an extra layer? What happens if you change hyperparameters? What happens if you change learning rates? Just have a go. It will give you a better intuition, and this is something that you need to be aware of, and it's quite important in creating your own models later on. So, like I said, if you're really stuck, adapt the code from the project lesson. So what I would do is bring it in, then change any of the state space observation things that are linked into the Unity environment. Don't worry about tweaking it or making it all fancy yet. Just try to get it running. Just make sure that code doesn't come up with errors, and it will do a basic training. And then this is something that after you get it training, then start actually breaking it down, looking at it, adding things, doing everything that you can possibly do to, improve it. And, it's a simple project to a degree compared to the next two, but it will give you a bit of an idea of, at least setting up in your Unity environment and going through there. Then probably once you get it up and running is optimize things. Now, one of the things, if you're using the workspace especially, don't run it in GPU mode, run it in CPU mode and do a little test run, maybe with, a few little episodes, just to make sure it doesn't jam up and that your code's working properly. Then when you're happy with your code, that's when I'd enable GPU and give it a good run to see, how it goes. Probably because this project doesn't have a very big state and action space, you can probably run it still in CPU mode if you want to save your GPU hours. But like I said, I highly recommend running in CPU mode, at least till you've got it ready to run a full proper training. Now, how would you? One of the things we talk about is don't just implement the project. We want you to push yourself, seeing what you can achieve. So some of the suggestions in the rubric is to include a GIF and a link to a YouTube video of a trained agent. Maybe solve the environment in fewer than 1,800 episodes. Now, 1,800 episodes, I will tell you right now, should be quite easy to achieve. And I've heard people, well, I know of people getting below 300. Anything below that's probably more likely they've had a bit of luck with learning rate and rate initialization, but you should be able to get around 300, and anything up to 800 is pretty damn good. And like I said, under 800, 1,800 is great anyway. If you've got time, write a blog post explaining the project and your implementation. So yeah, get yourself out there, show people what you can do. That's what we're trying to do, is have that confidence in showing what you've learned and what you can achieve. Now, once you've got the project, say, running with this basic deep queue network, I would highly recommend having a go at the double deep queue network, the DRLND deep queue network, and also a prioritize experience replay. Also have a go at the raw pixels version, which I'll talk about shortly. So it is the same environment, but instead of using 37 one-dimensional array, it uses pixels, so pictures. You'll need to use a convolutional network, of course, and it will be a lot more, much more of a difficulty to get it up and running and working. The other thing I'd suggest, and I've seen from students, is have a look at maybe some new information, a new paper. Try to implement something that no one else has done before. That shows that you truly have an understanding of what's going on, and that you can break down an idea and put it on. And I applaud anyone who can do that. But it also is way beyond what you probably need to pass the project. But it's not just about passing project. What we want to do is be able to do this in the real world. So trying to understand it and really breaking it down and pushing yourself is what we want. That's what employers will see, that you've done something beyond that. And depending on what you want to do, if it's academic or hobby, I highly recommend pushing yourself as hard as you possibly can. Now, I'll talk about the optional challenge. So basically, the optional challenge is using an 84 by 84 RGB image. Do not submit this. It's not required for the project. The first environment is what's required. It will take much longer to train, so either do it on a local PC, or if you've got some free GPU hours, have a go at it on basically, yeah, I would recommend using it on AWS. You can't train this environment on Udacity Workspace. So when I say GPUs, I actually meant maybe on AWS credit. If you've submitted for that, I highly recommend trying to get some credit. And if you've already got AWS, or you've got your own GPU set up, have a go at that. And one of the things which you'll find with this project is that you can't view it in the workspace. So you need to do that on a local PC to be able to actually see what's going on visually. So, if you can try it, if you have time to set up on your local PC, I definitely have a go. And I'm going to go through that a bit as part of this walkthrough. Now, what I'm going to do is I'm going to go through some of the workspace, and then I'll go through the code itself. And then I'm also going to look at local installs for Windows, Mac, Linux, AWS. And I was going to do Google Cloud platform, but I ran out of time, and I'll try to get that maybe for the next video next week or the next project. I have had a few students ask about that, and I did have a quick go, but got a few errors, and so I will probably go and review that next week. So the other thing which is really important is some of the Git repos that I would say definitely have a look at. So I'll bring some of these up. 2 seconds. All right, here it is. So this is the Udacity Deep Reinforcement Learning Git repo. So it's got all the projects in it, and basically down the bottom here, it's got the dependencies installed to set up. So Linux and Mac I found quite simple, and Windows I had a little bit more trouble getting it working. One of the things I would say is if you're trying to do any of the projects that aren't part of, any of the examples in here, follow this, install Gim and make sure you install those two bits. Now I've had a few people have problems with everything installing. So I would maybe recommend within the repo, which I'll just bring up, that you don't just install that if you're having problems. Say the lunar lander is not getting found. Also make sure if you're on OS X or Ubuntu that you run these first, because this could make a difference if you're installing everything. And then maybe do a pip install everything. Now you're going to get some errors anyway, because some of the stuff won't be ready to go, but it will make sure that most of it is installed, but it will take up more space. Now, if I go back to here, so this is the main setup, which I'm going to go through a little bit because there's a few modifications in that which I found to get it working properly. So I'll do that in a bit. Now, the main project is under P1 Navigation, which has the standard navigation and the Pixels version of the project. As you can see, this is what it looks like, cruising around. Let's try and collect bananas. So there's a bit of an explanation of what's going on. Here are the different environments that you need to download depending on your operating system. And this is also the no-viz version, which is used for AWS, this link here. This is the optional challenge. This is the environment for that. And here is a link down the bottom here, which probably gives you the best setup for AWS and the easiest setup, and also allows you to do an X server for the Pixels version. So I would recommend if you're doing any of the setups on AWS, probably use this one. This AMI works quite well, and only needs a very small alteration to what is actually said here to get it working properly with everything. So once again, I'm just going to go back here. So look, that's those three repositories that I'd look at, and now I'm going to go into the workspace and go through the code slightly. So bring that up. So I just have to wake up my workspace. So with the workspace, if you have any problems running particular things in any particular browsers, I'd recommend using Chrome. Tested it in a few, and Chrome seems to easily work the best. Now, for some reason, it is taking its time. I will just give it a little bit longer. Of course, when you do things live, some things don't work. While that's waiting to come up, I'll give it another moment or so. What I would suggest is, at least at the beginning, if you're having problems setting up environments or anything like that, what I would suggest is using the workspace. It's the easiest to run the implementation. Yes, you won't be able to see it visually, but it will probably give you the best way to start off. Now, I'm just going to flip out and flip back because it seems to be having an issue. Oh, there it goes. So you just need to click out and click back in. Now, one of the things here, make sure it says trust before you start, otherwise you may have some issues with certain parts of the project. Now, the project. So this is basically the starter code for you. So what I would suggest is, of course, maybe running all the cells and making sure you don't get any problems. You shouldn't in the workspace, and if you do, try a different browser like Chrome. So I'm just going to run through. So this basically is installing a few little bits and pieces. Now this is the main, so it's basically from Unity agents imported into Unity environments and NumPy, which is used. Now you'll probably have to put other imports in, for example, Torch, like PyTorch or whatever else you're using. But if you just run this, you shouldn't get any errors. Now, if you do get any problems, if it doesn't work for any reason, like I'm getting right there, that shouldn't probably take that long. I'm just going to give it another 10, 20 seconds just to see if it's all good. And that's probably taken too long. I would say that's usually quite quick. So what I would do is go interrupt kernel, restart the environment, then try it again. Wait for that to finish. And then try it again. That's better. So yeah, I find Jupyter does jam up a fair bit in both local, AWS, on here, all of that. So you do have to sometimes restart. If you get completely stuck and things are broken, you actually do a refresh workspace. So now the next bit. So basically, it contains brains, and there can be multiple brains. So it's developed to be out multiple agents. But if you do that, that will just initialize the brains. Now, this is a good thing to look at, examine the state and action space. So if I run that, it's basically printing out the number of agents. So there's only one agent in this environment. If you're using multi-agent, you might have multiple agents. The number of actions is 4, which is that move up, move down, left, right, which is an array of length of 4. As you can see, basically is the action space, similar to Jim. The state, this is where you're getting the state from, so this observation, so this will be what you have to plug in to your agent. And it looks like this, so it's a 37-dimensional vector, and it is just one dimension. Now, this will give you a bit of an idea of what's going on. So first thing, like similar to the Jim environment, does a reset, which gives the info of the environment. The state comes from the observation. So this is what, your state, if you're looking at rewards and things like that. Score at the moment is 0, and this is just a simple while loop. Now you'll do this probably different, very similar to maybe the environment that is in the example. As you can see, this is just doing a random action. Now this action would come from your agent. So your agent would perform this action based on the state that it's received. Now the next state, of course, then it runs a step and you get the next state. It also gets the reward, and it also gets whether it's done or not. And if it's done, the episode will finish. The score is basically the reward. Now if we run this, it will run for a little bit, and it gets a score of 0 because it's random. And it's probably just shaking around doing nothing. Now, the other thing which you want to do is, for example, if I make another piece of code and I go import Torch, Torch will work fine on this environment, as you can see, so you should have no problems with that. Now that we've gone through the code and the workspace, I'm going to attempt to install it on Windows, a Linux system, which would be similar to Mac, and AWS Live. Now, wish me luck, because as you know, setting up environments, typically you're going to get errors, but I will have a go. And I'll show you working through the errors that I may get. So for a local install on Windows, basically you want to go to the deep reinforcement learning repo that I just went to. You want to create and activate a new environment. So that's using conda create. You want to activate that environment. You want to git clone the actual deep reinforcement learning GitHub, cd into it, and do a pips install. Now in Windows, I got errors doing this, so I then had to run a conda install and then do a pip install for Unity agents for Windows. Now Linux, I had no troubles at all, but I will go through this. You then, once you've got it, the project, you want to get that particular P navigation and create a folder and put the P navigation project into that folder, or at least the contents of it. You then will need to download the environment, which is in project description as a README, unzip it and move the environment into a project folder or a folder underneath that you can access. You then want to run the Jupyter Notebook and test all the cells and make sure everything's working. Maybe check things like PyTorch as well, or import torch. So let's have a go at setting up the environment. So probably the simplest way is second. All right. So I'm going to bring up this. Now, if you follow the instructions, it says to do this. So let's follow the instructions. Now, I'm assuming that you already have Anaconda installed, and that you have Git installed as well, and that you're set up. I'm not going to go through that. That you can look up separately. But if you do get stuck, message me. So first, I'm just going to get create a Conda environment. So I've just copied that. Now I'm going to call this environment webinar for now. I've already created an environment before. Yes, for it to install things. It won't take very long. Probably will because I'm streaming at the same time, but we'll see how it goes. All right, next, activate the environment. Now we're in the environment. So what it suggests here is, if you wanted to do the OpenAI gym, you would do that side of it. But for the project, you just need to do a git clone. Now, you might as well do two things at once. So what I'm going to do is, you could do this just through folders. I'm just doing it with command line because I'm used to Linux. Webinar. So I've created a folder for webinar. I'm now going to do a git clone. So I basically copied that in, git clone repo. So that's installed, downloaded everything. I'm now going to cd into this Python directory. I'm going to try running a git install and see what happens. So it starts trying to install it. This may take a little while. Like I said, because I'm streaming at the same time, it may be slowing down a few things. Now, look, we've got some errors. What's going on here? So I found a simple way to fix this and get the environment up and running was to do two things. First, I went to PyTorch, found the stable release to their website, pytorch.org. I wanted a Conda install, Python 6 and CUDA 9, which I think is the requirement. Then I basically grabbed this and I have pasted that in. This will install in that webinar environment, the deep reinforcement learning content environment we've created. So this will take a little while to download and install. Yeah, it's going to take a little while, but yeah. So basically I found, I'm not sure why it doesn't install. It did install once before, so I'm not sure if it's a version of Windows 10 that I've got or Anaconda or what, but basically I'm just installing PyTorch separately because you will probably want that for your agent. Now the other thing which you must do is pip install Unity agents, because it didn't install them properly as part of the pip install from the Git repo. So this is very important, otherwise you're going to get an error when you try to use the Jupyter Notebook. Now that shouldn't take very long at all. It's almost done. Don't worry about that. Don't need pens board what you're doing. So probably actually one of the other things that you'll need to do while this is happening is by bringing this up. So this is the webinar folder, and this is all the things that have been pulled down. So you could leave this in here or create a separate folder, but basically the project files which have got the navigation are within this P1 navigation. So you could take that out and put it into a different folder and delete this altogether, as long as you've got them. But I'm going to leave it in there just for testing sake. So what you need to do as well is you need to go and go to the navigation project, and depending, because this is Windows, I'm on a 64-bit, I need to download this link. As you can see, I've already downloaded it previously, but if I grab it, and go into, so if you've taken this out, for example, I'm just going to put it in here. I'm going to unzip it. And it's down here. So I'm just going to copy that, and save some time. Now let's have a look at our install. Still going, almost done. Cool, so done. So I'm going to go cd dot dot. I'm going to go cd into the P1 location. You see everything in there. So we've put the main files in, we've unzipped them, and now we're going to just do a simple now basically what you want to do is grab that. It's gone up into another screen, but I'm not going to use that for now. If it pops up, great. Otherwise, I'm just going to copy this, put it into a separate folder. So here we go. We're up and running. You've got the two versions. You'll be using this version. So let's see what's going on. So basically, if you hit trust, I always recommend doing that. Now, first thing you want to try is make sure that Unity agents that we just installed work. So go, run it. What does it do? Yep, no errors. That's great. So everything's imported. Now we have to put in the banana environment. So as you remember, I'm on a 64-bit. I'm going to grab that information. And now that's not going to work because under here, it's actually a whole another layer deep. Now I could move this around, but I'm just going to show it to make it easy. So I'm going to go there. Now that should do something. Now I'm getting this pop-up, so I'm just going to say allow, and you'll see basically it will create a Unity environment on a screen, which will just be blank. Don't worry about it for now. It will actually, I'll show you what it looks like. So it's like this, nothing's really coming up. Now if I go through the rest of the code, which we went through in the workspace, and we start running it, this is what you'll see. Here it goes, doing random things. Woo. So as you can see, it's not really doing much because it's doing random command. You know, it's just, it might get a banana, it may not, but this will show you what's going on. It's good to visualize it. So as you can see now, what I will do now, I'm just going to take that off the screen and hit close environment. Now, one of the, where is it? That's it for now. Okay, so that's probably the simplest form. So now, probably the other thing you want to check, because you'll be doing PyTorch, is go import torch. See if you don't get any errors. No errors, so you should be good to go to start implementing that environment. All right, so now let's install on a Linux system or a Mac system, which would be very similar. Now, this is really easy, I found, on my Ubuntu 16, and I also did it on Ubuntu 18. So what I'm going to do, I'm just going to TeamViewer into one of my Linux systems. Hopefully just use the TeamViewer. Now, one thing that may occur is I'm just using a trial version that I might get kicked off, so I'll try to do this quite quickly. So I'm going to make that full screen. So hopefully you guys can see this. Now, what I'm going to do is similar to what I did with the other one. I'm going to bring up the deep reinforcement learning. I'm going to do the same as what I did with Windows. I'm going to do a content create. First, I'm just going to go into documents. MKDir webinar 2, CD webinar 2 list. I'm going to call it in 2. Now this is going to quickly install everything. Hit yes. We're going to do type that. Okay. Now, same deal as before. You can put all the OpenIO stuff if you're going to use this environment for the examples. Otherwise, do a git clone of the repo. CD in. And do a install. You'll probably see that this will do everything nicely without any errors at all. So, as this is installing, you'll probably see that down below I've got create an IPython kernel in the repo. Now you don't seem to need to have to actually run this, and I actually found that it gave me a few problems with certain versions. So run it if you want. You know, you're already in the environment. When you run the Jupyter Notebook, pretty much will run fine if you've got it all installed correctly. But I don't use it. I just basically do these few steps, and that seems to work fine. Now, while that's installing, I just like give it a moment. Everything's starting to get a little bit laggy. Actually, no. So by rights, if everything goes right, all I'll need to do is download the environment into the navigation folder and be ready to go. So there's 2 ways to do that. You can download it normally, or you can go something on there. You can go to here and grab you need to download that. I'm just going to copy the location, and I'm going to go cd p1 navigation. Now you can copy this to anywhere you want, as long as you've installed, done the pip install, you can now move this to anywhere you want, but I'm just going to leave it for there. So if you go wget the repo, this will quickly download the banana. You can also just download it in a browser if you want, but just doing it off command line because I live in the command line and I love it. Okay, next is just do a list, make sure it's there. So you go unzip underscore Linux dot now list. See if there's a folder there. Now it's a bit as simple as this. Go do by oops, notebook. And I run it. Oh, once again, do the trusted. Now, basically, make sure this works first. That's important. Now get the right environment, because it was the Linux. Grab this one here, 64-bit. Control V. This should just run. Look at that, Unity's come up. Now if I go here, 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 and now run the main loop, you'll see it's cruising around once again. So that was probably the sync. I find Linux was probably the easiest to install, and I find that actually most stuff Linux seems to be the best, and Mac seems to be really good as well. Windows, of course, always has Windows issues, but as you can see, I've got it up and running to show you guys how to do it, which was slightly different to the actual guide itself. So I'm going to close that, and I'm going to close down, leave the page, leave that, and get ready for an AWS setup. All right, so I'm going to close that for now. Now, so as you can see, I basically created the environment, did a conda create, source activate, clone the repo, cd into it, did a pip install within the Python directory, which installs everything. I then created a folder. I moved or used it within the space. Downloaded the environment. You could also use the no-viz if you don't want it to visualize. It will train much quicker. Unzip the file and move the environment file into the project folder. Run Jupyter Notebook and run through basically the cells and make sure everything's working. One of the things I didn't do was do an import torch just to make sure, but that will work fine. I actually tested that previously. So now AWS setup. Like I said, I would love to do Google Cloud, but I'm just going to work on an AWS setup for now and go through how to do that. So if you're, what I'll do is you will need to have an AWS account. Go to in Virginia, go to instances, launch an instance, and what I would recommend, I'm going to quickly go through that. The AMI, there's an AI image on this particular, which I'll show you that. Oops. Where is it? There, sorry about that. So under here, if you go to set up X server, there's an AMI image. Now do a search for this particular AMI image. If you go to community AMIs and do a search, here it comes up. So basically, select that. You would want to use a P1 minimum large. Now you want to make sure you got AWS credit because this will charge you, and you will probably have to ask for GPU support if you haven't on your account at least 48 hours before. So next, basically go configs. Now you probably leave all this default. You can change it if you are familiar with AWS. Storage, I am going to change it to 120 because I probably will use this later. I just want a little bit more space. Configure the security groups. Now you can create a new security group. Now I'm going to be super lazy here, just for demonstration. I'm just going to do all TCP. Now, what you could do is actually just do port 8888, which is for the actual Jupiter. I'm just going to say anywhere for now because I'm basically going to go back and change this later, but this will just get us up and running. And now go launch. Now, I've already made a key previously, which is on my laptop. And I'm going to launch the instance. Now, if you're not familiar with AWS, that might have that will hopefully show you how to do it. And I'm quite familiar with AWS, and like I said, I would like to do some testing with Google Cloud and maybe some other services, but we've got an image that's easily works. And what's great about this image that I've just done, it will also work for the Pixels version if you go through and where is it? Let's go back. Yeah, so you have to follow some of the other steps in here. Don't worry about this bit. I slightly changed that to work differently in my install. You also can set up X server. This is for the Pixels version, and you will need to do that. Or just run it locally. That's the other option too. If you've got a local setup, you can do that. So have a bit of read through this, but I'm going to just leave that now, and you won't need to do any of that to just train the standard version if you want. So if I go back to the instance, it's almost ready to go. Now, can I connect yet? Now, if you look at this, if your .pem file is downloaded, which you've created, and it can create and download, make sure if you do a change mode 400 on it, otherwise it won't work properly. One of the other things is, see how it says root here? You'll need to change that to Ubuntu, otherwise it won't work. I'm not sure why it comes up wrong. But it does come up wrong, and you will need to change that. So sometimes just refreshing. So it's still initializing. This may take a little while. So we'll just wait a little bit longer. Now I'm going to log into this using my Linux system because I don't want to use an SSH like PuTTY or anything, and it works beautifully on Linux. So I'll go through it that way. And I think Mac would be quite similar as well. So it's almost good to go. Just taking its time, of course. You know what it's like with PCs when you're waiting for things, they always seem to take longer. A bit like watching a kettle boil. Still initializing. So look, while it's initializing, I'll just talk about a few things. So you probably noticed that I didn't follow the directions exactly as presented in the repo README or in the information, because I found that this is probably the simplest way. I've done a few different setups and tested, and this seems to work without any itches at all. And there's a slight variation. So probably one of the things which I'll go through actually is in here, it says to do a git clone of the Unity Technologies ML agent git and do that. Don't do that. I think that caused a problem. We actually probably could do it, but there's a much easier way, which is just a simple setup, which I'll go through shortly. Still initializing. Look, they do take a while to initialize. I probably should have done this before. Oh, there it goes. So what I'm going to actually do is I'm going to connect into my Linux box. 2 seconds, because I would prefer to set it up that way. Okay, so in my Linux system, I'm going to go connect, and I've already done the change mode for the file previously, so I won't need to do that. File is in I think it's in downloads. So you need to have the file there. Now, one of the things you want to do is change that to Ubuntu. Yes. And we're into the terminal of the AWS instance. Now, if we do a list, it's got some basic stuff in it. So you want to do a source activate Python. I think it's Python. Let me just confirm on that 100%. Yes, Python 3. So this is activating. Ooh. I think I must have. That was. Try that again. Source activate Python 3. So now we're activating the environment. Now, what I would recommend, and this is what worked for me, is I went back to the main deep reinforcement learning. So doing a similar to what is set up in there, but there's an environment already made for us. And I'm going to do this bit. I'm cloning the environment. I'm going to put it in. And then I'm doing the same pip install that I did on the Linux system. This is Linux. So it should just work. Probably won't take as long as the other one, since it's on a AWS instance, and they have a lot more bandwidth than, say, my PC. So there it goes, installing everything. Now, while that's doing that, once again, I'm not going to use the iKernel bit. Oops. I'm going to go into the navigation project. Now you need to get the no-viz version, which is here. I'm just going to copy the location. And this is finished. Oh, so this is an error which you do get, sorry, on this one. So you need to do a pip install C Python. If that runs, then just do the pip install again and make sure you don't get any errors. Now you should be all good. Now I'm going to go into the P1 application, do a test list. Yep, everything's there. So I'm doing a wget of the no-viz file. I'm then going to do, I'm going to just make sure it's there. I'm going to do an unzip of the banana Linux no-viz.zip. Now that should be in there. Now, you can't strike Jupyter Notebook, it doesn't seem to work properly with this. So use this command. So it's basically Jupyter Notebook /IP equals 0.0.0.0 equals no browser. Now, while that does that, we'll start setting it all up. Taking a small amount of time. Almost there. Now, this is the token that you need to grab. So, copy it, put it into the browser. Let's see how that's not the right external IP. So what you need to do is go to your instance in AWS, copy it, and just replace that bit there. This will now open up the Jupyter Notebook. Now, what I found is when you first initialize the instance, and it's the first time that it's set up, it does seem to take a little bit longer to first sort of get things going. Once it's been running for about 5-10 minutes, it seems to be much, much better. So just give it a moment. It's getting there. Like I said, it does seem to be a little bit slow at the beginning, but it will end up loading in the end. Ah, there it goes. So once again, I will open up the navigation project. As usual, I will make sure it's trusted. And I'm going to go run that, no errors. I'm going to get the headless version, the no viz version for 64-bit. I'm going to run through the code, everything's running, no errors, and close. Oh, probably another important thing is this training mode to true. If you've got training mode to true, it will be super, super, super fast. If it's not on training mode true, it will be quite slow to train. It will do it basically rendering for visual. So yeah, you definitely want to put this in when you're training. That's super, super important. Otherwise, it's complete. It's going to just take way too long. One of the other things I would suggest, which you can pip install more stuff later, but just to prove that this is all ready to go for basically implementing a PyTorch implementation, I would do an import torch and make sure that works too. As you can see, that works as well. So one of the things with these instances, they are charged at a minimum of an hour, but I'm going to shut it down anyway now, so I'm not using any more credit. So I hope that's helped a bit with setting up different environments in different systems. So as you saw, I basically went to that site, I got that image, I launched an instance, I used that community AMI. I ran through the config, selected extra large, I opened up port by all ports, but you'd open up port AA. I launched the instance, created the key, and SSH'd into it. Basically then I've done a source activate Python 3, I've cloned the deep repo, I've done a pip install within the Python directory. I then had to do a pip install Python, then went into the navigation project and did a wget of this file. If you don't have unzip, you can do a apt-get unzip. Oops, unzip the file. Then a Jupyter Notebook browser, copy the URL from the terminal, replace it with the IP of the external IP of the instance, paste it in the browser and log into the Jupyter Notebook, run the navigation project and test cells, and then import. Now, I probably recommend training on this, but doing your code on your local PC if you can. But if you're running an instance or whatever, anyway, that's up to you. Now, some extra reference material that I would go through, because we're getting a bit over time, is have a look at this repo, this one and this one. They've got some great implementations in PyTorch, not of the project, but of different variations, double, dualing, and rainbow. So I highly recommend looking at that. Now, I'm just going to see if anyone has any questions. So I have a Q&A. I'll give 1 minute for any questions, and otherwise I will finish up and talk to you guys all next over the following week, and see how you're going with the course material. And like I said, if you have any problems with what I've provided, direct message me or message it in the channel, and I'll go through it with you. So hopefully this was help you for both the project, what you need to do, and also how to set up different environments, which I think is good to know how to do that. And one of the students asked me about a Docker environment. I will probably try to set up a Docker environment into a GitHub and link it to you all if you want. And also, if I get Google Cloud tested and working, I'll flick through a link to that as well. Maybe do a little just a readme of how to set that up. So no one's had any questions that I can see. Well, look, thank you very much. Like I said, if you have any issues, contact me. I'm always available, and I'll try to get back to you as soon as possible with any questions that you may have. Once again, thank you very much for attending this webinar, and I will talk to you guys soon. Thank you.